Hey guys, it's Mr. Herbst here, and today's focus is going to be on the evidence for evolution. Now in science, we like to go ahead and break down the evidence for evolution in four main categories. We have fossils, otherwise known as how does evolution show itself within the fossil record. We also have structures. How does evolution show itself in the structures of organisms? We break it down into three major categories when it comes to structures. Those are homologous, analogous, and vestigial structures. We'll go ahead and focus on that in a minute. The next thing is embryology, otherwise known as the study of embryos. How do embryos show that evolution has happened? And the last thing is within DNA itself. How does DNA point to the fact that evolution may have had happened? Now when I'm going through this PowerPoint here, I'd like you guys to go ahead and think, do you think that all of these things could have happened by random chance? Otherwise known as, do you think that this could have happened randomly? So the first thing I want to go ahead and focus on here, guys, is the fossil record. Otherwise known as, how does the fossil record show us that evolution may have occurred? Now, if we take, for example, or if we consider, for example, the modern-day camel, the fossil record shows that the modern-day camel did not exist when the dinosaurs were around. However, the fossil record does show us that when the dinosaurs were around, or shortly after the dinosaurs went extinct, we found this organism that kind of resembled modern-day camels. Otherwise known as, it had some similar features to modern-day camels, but it probably looked way different. It was, in fact, probably far smaller than modern-day camels. And what the fossil record shows us is that as time continues, the changes to this organism here began to resemble a modern-day camel more and more. More specifically, those examples would be in the teeth and the skull and the bone structure of this modern-day camel. And so the fossil record kind of shows us that evolution, or the change in how what an organism looks and behaves like over time, has occurred. The next thing I kind of want to focus on here, guys, is structures. Otherwise known as, how do structures of modern-day organisms kind of show us that evolution may have occurred? And the first thing that I want to take a second to focus on is homologous structures. Homologous structures are structures found in modern-day organisms that may have different functions within the organism, but nonetheless, at the actual structural scale, they are very similar. For example, if we take the modern-day turtle, the alligator, the bird, and the mammal, and we compare them, even though the arm bone, or the front bone, or the front arm, paw, or limb of each one of those organisms on the outside may look very different, on the inside, the actual bones and the structures that make up that arm are very similar. For example, if you take a look here, all of these organisms have one similar bone in common, and that is the humerus. And then if we go ahead and look at it even further, a lot of these organisms both have a forearm bone that works in the same way, such as the radius and ulna. All right, so the next thing I kind of want to focus on here is analogous structures. Analogous structures are sort of the opposite thing of homologous structures, where in analogous structures we may have different structures, or the way that those organisms, things are designed, but they serve similar functions. Now what do I mean? Let's take, for example, here the insect, and a pterodactyl, and a bird, and a bat. If you look at the way those things are organized, and even if you look at an insect, they don't even have bones at all. But what do all of these organisms here have in common? Yeah, that's right. They all have the ability to fly. And so that's the function that they all share in common. But the way that they fly is all a little bit different. So analogous structures are structures that may have some similar functions within certain organisms, but the way that they kind of are put together is different. Another piece of evidence for evolution is these things called vestigial structures. And now when I teach about vestigial structures, I like to look at the root word there, vest. If you look at a vest on a human being. A lot of people spend a lot of money to buy vests, right? But what do vests actually do for you? Do they keep you warm? Do they keep you cool? The answer is no. Vests basically serve no purpose at all. And that's what vestigial structures are very similar to. Vestigial structures don't really serve a purpose within an organism. And one thing that we like to use a lot, or an example of it that we like to use a lot in science, is the appendix right here. Appendix is a little organ that's about the size of your pinky that's attached to your colon. And it really doesn't do anything besides get inflamed, make you sick, and make you get surgery. I mean, really, it doesn't really do much at all. But if you consider organisms like cows and horses, their appendix does a lot for them. It helps them to break down grass. Now, us human beings don't really eat grass anymore, so our appendix doesn't really serve very much of a purpose within us. And finally, another thing that supports the evidence for evolution is the similarities within embryos. A root word here in embryology is embryo. If we take a look at the similarities between a fish, a rabbit, and a gorilla, more specifically, if we take a look here at what I'm circling, the embryos are before you were even born, you were an embryo. So while you were still in your mother's womb, the little baby organisms, they all kind of look the same, right? Now, when you look at that, ask yourself, could that have happened by random chance? Or do you think that all of life, or at least animals, kind of share some similarities? Now, eventually, as life goes on and these organisms develop, they become different, or they start to look very different. Obviously, a gorilla looks a lot different than a fish, but at one time in their lifespan, they shared some very big similarities, and those similarities were when they were an embryo. Do you think that could have happened by random chance? And finally, one of the coolest similarities that all of life has, and one of the biggest evidences for evolution, is the fact that all of life shares the simple molecule called DNA. A bacteria, a rabbit, a cow, a reptile, an amoeba, an algae, a plant, all those things have DNA. Do you think that that could have happened by random chance? Or are all these things somehow related to one another? Or did they all kind of evolve from one another? Organisms that are closely related share more DNA with one another than others. And finally, the last thing I want to leave you with is the thinking. Now, based on those four big things, those four similarities between all of life, do you think that that could have happened by random chance? Or was there some sort of force that has led, that we all sort of are interrelated with one another from sort of a family tree of organisms, and eventually we sort of all budded off of that family tree, otherwise known as evolution? Do you think that all those similarities between life could have happened by random chance? Anyway, guys, this is Mr. Herbst. Hope you learned a little bit more about how the way evolution works. I'm signing off, folks. You all have a nice day.